Hello, we are discussing about GATE 2010 ECE paper. In the circuit shown, the switch S is open for a long time and is closed at t is equal to 0. Find the current I of t for t greater than or equal to 0 plus. That is, you are going to find the expression for I of t for any time t. Okay. So it has given that one, the circuit. In this circuit, switch S is open for long time. That means for t less than 0 minus itself, circuit reaches steady state. Okay, before the switch is closed, the circuit is going to be in steady state. So the circuit reaches steady state. I am writing, whenever the circuit is in steady state, by the time inductor, this is L, inductor act as short circuit. Inductor act as short circuit, okay, for in steady state. So simply you are going to calculate the initial current which is flowing just before the switch is closed. That we are going to calculate. Okay, so then the equivalent circuit is going to be looking like this one. This is current source following with 10 ohms. And next, switch is open, so it doesn't have any effect, so I am not writing that one. And then this is 10 ohms and this inductor is acting as short circuit. Okay, switch is open, so I am writing like this. I am not indicating the resistance value also. So this is 10 ohms. Now the current can only go through this 10 ohm and this 10 ohm. That will be, both are in parallel. So this is what equivalent circuit you will get. And the current source is 1.5 milliamperes. It is 10 ohms and it is also 10 ohms. So current flowing through inductor is nothing but current flowing through this 10 ohms. So IL inductor current at 0 minus under steady state is equal to, using current division rule, both the resistances are same, so that half of the current will flow in both resistances. So 1.5 divided by 2, which is nothing but 0.75 milliamperes. Okay, IL of 0 minus, so 0.75 flow in this one, 0.75 flows in this one, because both resistances are same. You can do the current division rule also. You can use the expression for current division rule, you can get this value. So 0.75 milliamperes is the initial current, and later whenever the switch is closed, again the inductor charges current, because the currents are going to be getting changed, and again inductor is going to achieve a new value of current. It may be less or more, but inductor achieves a new value. Okay, while inductor is achieving a new value, remember this one, this inductor is in parallel with these resistances. So whenever inductor current is going to be increases, at that time current flowing through these resistances is going to be gets reduces. If the inductor current is going to be gets reducing, then the current flowing through these resistances is going to be increases. Okay, since resistor is a linear element, if inductor follows exponential behavior, okay, if inductor current increases exponentially, then I of t, current flowing through this resistor, decreases exponentially. This current is also decreases exponentially. If inductor current decreases exponentially, this current increases exponentially. Okay, so now if you want to write this I of t is going to be a exponentially changing current, that is exponentially varying current I of t. For that one, we are going to use general expression. Okay, general expression for I of t, current I of t at any time t changing exponentially, which changes exponentially, can be written as I of t is equal to I of infinity plus I of 0 minus I of infinity into e power minus t by tau. This is what the expression for the current or voltage. This can be used whenever any waveform which changes exponentially with some time constant. So this is a general expression. I of t is equal to I infinity. I infinity is steady state, final value, and this is I of 0 is initial value, I of infinity is final value. So you can write the same thing as if plus I initial value minus if into e power minus t by tau. So what we require from this expression is, we require the initial current flowing through this resistor and final current flowing through this resistor under steady state. We require these two parameters as well as time constant also. Now we will calculate initial value and final value of I of t. Initial value of I of t is whenever the switch is closed. Okay, so first case, when switch is closed. So at t is equal to 0 plus, that means switch is closed, that is initial value. So I of 0 plus is nothing but I initial, which is II. So this value we require. Okay, whenever the switch is closed, how much current is flowing, that we are going to find. And we know that when current flowing through this inductor, just before the switch, current flowing through inductor is 0.75 milliamperes, and just after the switch also current is same in the inductor, because inductor opposes sudden changes in the current. So since inductor opposes sudden changes in the current, we know that when IL of 0 minus is equal to IL of 0 plus, which is nothing but 0.75 milliamperes. So this is 1.5 amperes. This is amperes, not milli. It is simply amperes. Okay, so 1.5 amperes. Out of that one, current flowing through this one is 0.75 amperes. So what is the remaining current? 1.5 minus 0.75. That 0.75 current has to go through these two resistances. Now the switch is closed, so the 0.75 by 2 will go in this side and 0.75 by 2 will go in this side, because both resistances are same value. So same current is flows. Same current means same value resistance is half of the current. 0.75 by 2, 0.75 by 2. So from this one we can write I of 0 plus is equal to 0.75 by 2, which is 0.375 amperes. Now under steady state, after switch is closed, steady state is reached as t tends to infinity. By that time again inductor acts as, okay, L acts as short circuit. Okay, inductor acts as short circuit under steady state. Even after the switch is closed also inductor reaches steady state. Before the switch is closed also inductor reaches steady state, because it has been given for a long time, 1.5 amperes. So don't bother about this one, how many times inductor is getting short circuited. Okay, inductor can get short circuit. So based on the circuit conditions, now also inductor gets short circuit, can reach steady state, and it will be acting as short circuit. Then that situation is going to be treated as this one. Now it is equal to 3 resistances in parallel, because inductor is acting as short circuit, so that simply all 3 resistances are in parallel, and this is the current source which is supplying for these 3 resistances, 1.5 amperes. All resistances are going to be having the same value, so that simply current flowing through each resistor is 1/3 of total current. All the resistances are having same values. You can also use the current division rule, but directly you can write current flowing through in this resistor. Any resistor is same, because all resistance values is same. So this I am writing it as I infinity, which is nothing but IF. Okay, which is equal to 1.5 divided by 3, which is 0.5 amperes. So now we know I infinity, we know I 0 also we know. Okay, I of 0 plus is 0.375, I of infinity is 0.5 amperes. What we require is time constant. Okay. So we will calculate time constant and later we are going to substitute it in the equation. So time constant can be written as, time constant is for RL circuits, time constant is L by R. Time constant is L by R for a simple RL circuit, but here there are so many R resistances are present, so we will write it as R equivalent of the circuit. Only one inductor is present, that is L, and it has 3 resistances. So we are writing it as R equivalent. What is equivalent resistance? Okay, when you are looking into inductor. When you are looking into inductor, what is equivalent resistance? So whenever you are going for the R equivalent, by that time, if any current sources are existing, they will be act as open circuits. Okay, so that simply they will be open circuit, and if any voltage sources are present, they will be act as short circuits. So by that time, if you are going to check about R and this R, both are in parallel, plus it will be added with this 10. So R equivalent is equal to 10 parallel 10 plus 10. So R equivalent is equal to 15 ohms. 10 parallel 10 is 5 plus 10, 15 ohms. So tau can be written as L by R equivalent. L means 15 millihenry, 15 millihenry divided by 15 ohms. So this will be equal to 1 millisecond. 1 millisecond. Tau value is 1 millisecond. So this is the equation for the current. Okay, and we know I of 0 plus is equal to, I of 0 plus is 0.375 amperes, and IF, that is I at infinity, which is IF, this is II. IF is equal to 0.5 amperes and tau is equal to 1 millisecond. Okay, that means 10 power minus 3 seconds. Substitute I of t value. I of t is equal to IF, that is 0.5 plus II, which is 0.375 minus IF 0.5 into e power minus t by 10 power minus 3. So this will be equal to 0.5 minus 3, 0.375 minus 0.5, that will be minus 0.125 e power minus 1000 t. So this is the expression for the current. I of t is equal to 0.5 minus 0.125 e power minus 1000 t. So the right option for this question is A. A is the right option. A is the right option. 0.5 minus 0.125 e power minus 1000 t amperes. Thank you.